Look up at the night sky. What do you see? Pinpricks of light, distant stars, the vast emptiness of space. But what if one day that emptiness suddenly yawned open, revealing a darkness so deep it devoured everything in its path? A black hole, cosmic vacuum, cleaners with gravity so intense not even light can escape. Now picture this: a black hole, silent and unstoppable, drifts into our solar system. Its pull tugs at Earth's orbit, bending the very fabric of reality around us. What happens next? Would we even see it coming, or would our planet and everything on it vanish in an instant, swallowed whole by the universe's most terrifying phenomenon? Black holes are more than just science fiction. They're real, lurking in the cosmos, and their power is almost beyond comprehension. A single one could compress our entire planet into a speck smaller than a marble. But what would that actually look like? Would time stretch and warp as we're pulled in? Would the skies above us twist into impossible shapes? The answers are stranger and more chilling than anything Hollywood could dream up. This isn't just a doomsday scenario. It's a window into the extremes of physics, a chance to explore the rules that govern our universe when pushed to their limits. Over the next few minutes, we'll unravel the science behind this nightmare, from the moment Earth's fate is sealed to the bizarre final seconds before everything changes forever. Buckle up, we're diving into the abyss. A black hole isn't some mystical void, it's a collapsed star, a cosmic carcass packing the mass of an entire sun into a space smaller than a city. Imagine crushing Mount Everest down to the size of a sugar cube. Now scale that up to stellar proportions. When a massive star burns through its fuel, it can't fight gravity's pull anymore. It implodes, collapsing inward with such force that space and time warp around it. The result, a gravitational grip so fierce, even light gets dragged in like a leaf caught in a storm drain. At the heart of every black hole lies the singularity, a point where matter is crushed into infinite density, where physics as we know it breaks down. Surrounding it is the event horizon, the point of no return. Cross that invisible line and escape becomes impossible. Think of it like a waterfall's edge. Once you go over, there's no climbing back up. But here's the twist, it's not some cosmic shredder. If Earth were pulled in, we wouldn't be instantly torn apart. Instead, gravity's tidal forces would stretch our planet like taffy in a process called spaghettification. The side closest to the black hole would feel a much stronger pull than the far side, elongating everything into a noodle of doom. Yet black holes aren't just destroyers, they're also cosmic laboratories. Their extreme conditions reveal secrets about gravity, space-time, and the universe's very fabric. Einstein's theory of relativity predicted them over a century ago, but we're still uncovering their mysteries. Some spin like whirlpools, dragging space-time around them like a twisted sheet. Others lurk quietly, invisible until they start devouring nearby stars, their feasts glowing with X-rays as matter spirals into oblivion. So, could one actually reach our solar system? The nearest known black hole is about 1,600 light-years away, comfortably distant. But if one did wander close, we'd notice long before doom arrived. The night sky would distort, constellations bending like reflections in a funhouse mirror. Tides would surge unpredictably, and time itself would slow as gravity's grip tightened, stretching seconds into eternities for anyone unfortunate enough to watch. The universe, it turns out, has far stranger ways to end than fire or ice. Let's break down the nightmare scenarios where Earth could actually meet its end inside a black hole. First, imagine a rogue black hole, a lone wanderer drifting through the galaxy, suddenly veering into our solar system. These cosmic nomads are thought to be leftovers from the chaotic early universe, flung across space by violent collisions or the explosive deaths of ancient stars. If one passed even remotely close, its gravity would wreak havoc long before it got here. Planets would be yanked from their orbits like marbles scattered across a floor. Earth could be flung into deep space or dragged inward, spiraling toward oblivion. But here's the twist, we might not see it coming. Unlike stars, black holes don't glow. They're invisible unless they're actively feeding on surrounding matter. The first warning could be subtle satellites glitching as their signals bend around unseen gravity, or telescopes catching distant stars flickering as their light stretches into unrecognizable streaks. By the time we noticed planets shifting course, it might already be too late. The pull would start gently, a faint tug distorting tides and stretching days. Then, as the black hole closed in, that tug would become an inescapable grip. Now, consider the second scenario, Sagittarius, a star, the supermassive black hole at the heart of our galaxy, suddenly waking up. Most of the time, it's quiet, a sleeping giant 4 million times heavier than our Sun. But if a nearby star or gas cloud stumbled too close, the ensuing feast would unleash unimaginable energy. Jets of radiation and plasma would shoot out at nearly the speed of light, sterilizing anything in their path. While we're 26,000 light-years away, a safe distance for now, an active galactic core could still bathe our solar system in deadly X-rays over centuries, slowly stripping away our atmosphere. In either case, Earth's final moments would be surreal. As tidal forces overpowered our planet's gravity, the ground beneath us would begin to warp. Skyscrapers would lean like trees in a hurricane, their foundations torn upward. The oceans would bulge toward the sky, suspended in monstrous waves before evaporating into superheated plasma. And then the spaghettification, a term as bizarre as the process itself. The difference in gravity between your head and your feet would stretch you like putty, atoms unraveling into a stream of particles spiraling toward the singularity. Time would distort too. From an outsider's perspective, Earth's plunge would seem to slow, freezing at the event horizon as light struggled to escape. But for anyone on board, it would all be over in seconds. This isn't just doom-mongering, it's a stark reminder of how fragile our place in the universe really is. Black holes expose the raw power of gravity, a force that shapes galaxies yet can erase worlds without a trace. And while the odds of one swallowing Earth are vanishingly small, the physics behind it teaches us something profound. The universe doesn't operate on human timescales or care about our survival. It follows rules we're only beginning to understand, rules that, under the right conditions, could rewrite our fate in an instant. The first sign wouldn't be a dramatic explosion or a blinding flash, it would be something far more insidious. The ground beneath your feet would start to ripple like water disturbed by an unseen hand. At first, it might feel like a minor earthquake, but then the tremors would grow stronger, more erratic, as tidal forces from the black hole's gravity began pulling the planet apart. The crust, once solid and unyielding, would fracture like thin ice under pressure, great chasms splitting continents in half. Mountains, those ancient sentinels of stone, would crumble as if they were made of sand, their peaks collapsing inward as gravity warped the very bedrock they stood on. Oceans would revolt next. Tides, normally governed by the moon's gentle tug, would surge erratically, waves towering higher than skyscrapers before crashing back down with catastrophic force. Coastal cities would vanish in seconds, swallowed by walls of water moving faster than sound. The air itself would grow heavy, thick with debris and superheated vapor as the atmosphere began to strip away, ripped into swirling tendrils by the black hole's pull. But the most unsettling change would be in the sky. Stars, once fixed in their constellations, would stretch into grotesque smears of light, their images distorted by the black hole's gravitational lensing. The sun, our steady, reliable sun, would appear to warp, bending around the darkness like a dying ember circling a drain, and then time itself would start to unravel. For anyone watching from a safe distance, Earth's descent would seem to slow to a crawl as light struggled to escape the black hole's grip. Seconds would stretch into minutes, minutes into hours, the planet frozen in a ghostly twilight at the edge of the event horizon. Yet for those on the surface, reality would accelerate. The final moments would pass in a blur of crushing gravity and blinding heat as the planets remain spiraled into the abyss, atoms torn apart in a silent scream. This isn't just destruction, it's transformation. Matter doesn't vanish inside a black hole. It's compressed beyond recognition, shredded into its most fundamental components. The iron in our blood, the silicon in our rocks, the oxygen in our air, all of it would be reduced to a swirling stream of particles, adding infinitesimally to the black hole's mass. In that way, Earth's story wouldn't truly end. It would simply become part of something far older and stranger, a hidden chapter in the universe's grand, indifferent ledger. Crossing the event horizon isn't like stepping through a doorway. It's more like being caught in a river's current where the water suddenly moves faster than you can swim. Up until this point, the black hole's gravity has been pulling at Earth, distorting our planet and stretching time. But once we pass that invisible boundary, every law of physics we rely on begins to unravel. The event horizon isn't a physical barrier, it's the point where gravity wins. Light, the fastest thing in the universe, can no longer outpace the black hole's pull. From here, every path, every possible direction leads inward toward the singularity. Inside, space and time swap roles. Outside the event horizon, we move freely through space while time flows forward. But once inside, falling toward the singularity becomes as inevitable as time passing in our normal lives. There's no stopping, no turning back. Imagine being in an elevator with its cables cut, except the elevator shaft is infinitely deep and the walls are collapsing around you. The bizarre part, you wouldn't even feel the moment you cross the threshold. The event horizon doesn't announce itself with a jolt or a flash. If you were falling in, you'd only realize your mistake when you looked back and saw the entire universe compressed into a shrinking circle of light above you, like peering up from the bottom of a well. For Earth, this would be the point of no return in the most literal sense. The planet's remains, now a spiraling stream of superheated debris, would continue their fatal plunge. But here's where things get even stranger. According to quantum mechanics, black holes might not be the eternal prisons we once thought. Stephen Hawking proposed that they slowly leak energy, emitting what we now call Hawking radiation. Over unimaginable timescales, this process could cause a black hole to evaporate entirely. But don't mistake this for a way out. Any information or matter that fell in, including what was once Earth, would be scrambled beyond recognition, transformed into a form of radiation so faint it's nearly impossible to detect. This paradox, the clash between relativity's deterministic laws and quantum mechanics' uncertainty, lies at the heart of modern physics. Some theories suggest black holes might preserve information in hidden ways, encoded on their event horizons like a cosmic hard drive. Others argue the information is truly lost, rewriting the rules of cause and effect. Either way, one thing's certain: for Earth, the journey beyond the event horizon would be the ultimate one-way trip, a dive into the unknown where the very fabric of reality ceases to behave as we understand it. The singularity awaits not with a bang, but with the silent, inevitable crush of gravity's final victory. Beyond the event horizon, the rules of reality bend to the black hole's will. Scientists have spent decades theorizing what might lie in that unfathomable darkness, but the truth is, no one knows for certain. The singularity, the black hole's core, is where all matter is crushed into an infinitely dense point, a place where gravity becomes so intense that space and time cease to function as we understand them. Some models suggest it might be a gateway, a tear in the fabric of space-time that could lead to another universe, or even a wormhole shortcutting across the cosmos. But here's the catch: these ideas remain pure speculation, because once something crosses that threshold, it's lost to us forever, leaving only equations and imagination to fill the void. One of the most startling debates among physicists is the firewall paradox. According to quantum mechanics, the event horizon shouldn't feel any different from empty space: no dramatic heat, no walls of flame. But when calculations are pushed to their limits, they suggest an alternative, a searing barrier of energy that would incinerate anything falling in. This contradiction pits Einstein's theory of relativity against quantum physics in a battle with no clear winner. If the firewall exists, it would mean the universe has a cruel way of enforcing its no-return policy. If it doesn't, then our understanding of quantum entanglement might need a radical rewrite. Then there's the holographic principle, a mind-bending notion that all the information swallowed by a black hole isn't lost inside but instead encoded on its event horizon like a cosmic fingerprint. Imagine your entire life being flattened into a two-dimensional shadow on the surface of a sphere, every memory and atom preserved in a form we can't yet comprehend. If true, black holes might not be the ultimate erasers but the universe's most efficient archivists. And what about wormholes? The equations of general relativity allow for their existence, tunnels through space-time connecting distant regions or even different universes. But there's no evidence they're real, and even if they were, traversing one would require exotic matter with negative energy to keep it stable. Otherwise, the gravitational forces would snap the tunnel shut faster than you could blink. For Earth, this would mean not annihilation but transportation, an unfathomable journey to some distant corner of existence, assuming anything survived the trip intact. The most unsettling theory, that singularities might not be in points at all, but cosmic reset buttons. Some models suggest they could trigger new big bangs, birthing fresh universes with their own laws of physics. In this scenario, the remnants of our planet might become the primordial soup for an entirely new reality, one where the concept of Earth never existed. All these ideas share one thing in common. They push science to the edge of its understanding, where mathematics meets mystery. Black holes force us to confront the limits of human knowledge, revealing just how much we still don't know about the universe's deepest secrets. Whether they're gateways, shredders, or cosmic archives, one thing's certain: they're far more than just holes in space. They're the universe's most enigmatic puzzles waiting to be solved. Earth vanishing into a black hole wouldn't just be an isolated catastrophe, it would send shockwaves through the entire solar system. Picture a giant removing a single brick from a carefully stacked tower. At first, the structure might wobble but remain standing. Then, as the imbalance spreads, the whole thing collapses. Without Earth's gravitational influence, the delicate dance of planets would descend into chaos. Mars, our closest neighbor, might drift inward, its orbit destabilized by the sudden absence of our planet's subtle tug. Venus could follow, veering unpredictably closer to the Sun. Even gas giants like Jupiter, with their enormous mass, would feel the ripple effects over time, their paths subtly altered in ways that could send comets and asteroids careening off course. But the real existential threat lies farther out. The Kuiper Belt, a ring of icy debris beyond Neptune, is held in check by the Sun's gravity, but Earth's disappearance could disturb that balance. Imagine a snow globe shaken violently. Countless icy bodies, some as large as mountains, might be flung inward, transforming the inner solar system into a cosmic shooting gallery. The asteroid belt between Mars and Jupiter could erupt into chaos, with collisions sending debris spiraling toward whatever planets remain. And what of the Sun itself? While a black hole swallowing Earth wouldn't directly endanger our star, the long-term consequences could still be dire. Planets like Mercury, already scorched by solar radiation, might spiral into the Sun over millennia, their orbits decaying without Earth's stabilizing presence. The Sun's delicate gravitational harmony, fine-tuned over billions of years, would unravel, leaving the survivors in a system growing increasingly hostile. Humanity's remnants, if any existed, would face an impossible challenge. Space colonies orbiting Mars or floating in the asteroid belt would suddenly find their celestial maps obsolete. Navigation systems relying on Earth's position would fail, leaving ships adrift in a sea of shifting orbits. Lunar outposts might last longer, but without regular supply runs from Earth, their fate would be sealed. Even the Voyager probes now drifting in interstellar space would carry an eerie message. Their trajectory calculations based on Earth's location would become relics of a world that no longer existed. Yet amid this devastation, there's a chilling irony. The light from our sun takes over 8 minutes to reach Earth, meaning if our planet were swallowed whole, the solar system would continue bathed in sunlight for those final moments, blissfully unaware. The sun would keep shining, the planets would keep moving, and somewhere in the cosmos, Earth's last reflected glimmer would still be traveling outward, a ghostly farewell to the universe it once called home. Even if we spotted a black hole years before impact, escaping Earth wouldn't be as simple as boarding a rocket. Current spacecraft crawl at a snail's pace compared to cosmic threats. It took the Voyager probes over 40 years just to reach interstellar space. To outrun a black hole's gravitational grasp, we'd need ships capable of relativistic speeds, harnessing technologies that exist only in theory, like antimatter engines or warp drives. Picture a global evacuation where every nation scrambles to build generation ships, massive arcs carrying frozen embryos, cultural archives, and enough supplies for centuries-long journeys. But here's the brutal math. Even if we launched thousands of vessels, only a fraction of humanity could flee. Who decides who gets a seat? Governments. Lottery systems, the wealthy. This isn't just engineering, it's a moral minefield. Some scientists propose a radical alternative. Don't outrun the black hole, use it. The energy swirling around these cosmic monsters dwarfs anything we've ever harnessed. Imagine capturing the intense radiation from an accretion disk, like tapping into a galactic power plant. Advanced civilizations might build Dyson spheres around the black hole itself, converting its lethal energy into a lifeline. But this assumes we'd have centuries to prepare and technology millennia ahead of ours. More realistically, we might attempt to manipulate the black hole's path. Theoretical concepts like gravitational wave nudges or dark matter scaffolding could in extreme scenarios alter its trajectory, though the risks of backfiring are catastrophic. One wrong calculation and we might accelerate our doom instead of averting it. Then there's the digital solution, uploading human consciousness. If physical escape is impossible, perhaps we could preserve minds in quantum computers, launching them into space as streams of data. These mind arcs would need no life support, just energy to sustain their servers, but this raises haunting questions. Is a digital copy truly alive or just an echo? Would we be saving humanity or creating a post-human relic? And even if we perfected the tech, storage limitations might force impossible choices. Do we prioritize artists, scientists, or a random sampling of every culture? The ethical weight could fracture societies long before the black hole arrives. Survival might hinge on rewriting our very biology. Cryogenics, suspended animation, or genetic modifications for extreme environments could buy time. Some extremophiles on Earth survive vacuum and radiation. Could we engineer humans to withstand similar horrors? But turning ourselves into cosmic tardigrades still wouldn't solve the core problem. Black holes don't just kill. They unravel reality itself. In the end, survival strategies reveal less about physics and more about us. Faced with an inescapable threat, would we come together or splinter? Would we pour resources into hopeless escapes or accept our fate with dignity? The black hole doesn't care, but our choices in its shadow would define what it means to be human. The black hole doesn't stop with Earth. As our planet's remnants spiral inward, the black hole feasts, growing heavier with every atom absorbed. An accretion disk forms a glowing, superheated whirlpool of debris where what was once continents, oceans, and civilizations now orbits at near light speed, friction turning matter into blinding radiation. To alien astronomers millions of light years away, this violent feast would appear as a sudden flare in the darkness, a burst of X-rays and gamma rays marking Earth's final moments. But to them, it's just another cosmic event, a flicker in the endless night. Over millennia, the black hole's appetite would reshape the solar system. Mars, stripped of Earth's gravitational influence, might drift into a chaotic orbit, colliding with asteroids or even Venus. The asteroid belt could destabilize, sending rocky projectiles hurtling toward the Sun or ejected into interstellar space. Jupiter's massive gravity might capture some, while others could become rogue asteroids wandering the galaxy for eternity. The Kuiper belt and Oort cloud, no longer held in check by the Sun's balanced pull, might disgorge comets like a scattered deck of cards, some plunging toward the inner system, others flung into the void. The black hole itself, now slightly more massive, would continue its lonely journey. If it were a stellar mass black hole, it might drift for eons, invisible and unnoticed, until another star or gas cloud wandered too close. If it were supermassive, it could anchor a new, smaller solar system, one where planets orbit an abyss instead of a sun. Civilizations rising there would never know what existed before, their night skies empty of the star we called home. But the most haunting possibility, light, the photons carrying Earth's final images, our cities, our oceans, our faces, still travel outward at light speed. A distant alien world with technology far beyond ours might one day catch those fleeting signals. They'd see Earth not as a ruin, but as it was in its last moments, a blue-green jewel unaware of its fate. To them, we wouldn't be gone, we'd just be late. This nightmare scenario isn't just about destruction, it's a masterclass in cosmic humility. Black holes, once dismissed as mathematical oddities, force us to confront the raw power of gravity. Every ripple in space-time, every stretched second near the event horizon, confirms Einstein's century-old predictions with terrifying precision. Consider LIGO gravitational wave detections. When two black holes collided over 1 billion light-years away, they shook the fabric of the universe so violently that Earth's sensors wobbled by less than a proton's width. That faint tremor proved these monsters don't just lurk in theory, they're out there, bending reality itself. Yet for all their violence, black holes also expose the delicate balance that keeps Earth safe. Our planet orbits in a galactic sweet spot far enough from the Milky Way's central black hole to avoid its pull, yet close enough to benefit from the stabilizing gravity that shapes our galactic neighborhood. It's a reminder that habitability isn't just about water and atmosphere. It's about location, location, location in the grand cosmic real estate market. Even Jupiter plays bodyguard, its massive gravity deflecting asteroids that might otherwise threaten us. One misplaced black hole could unravel this intricate safety net in moments. There's a deeper lesson here about time. A black hole doesn't just crush matter, it warps our perception of reality. To an outside observer, an object falling in appears frozen at the event horizon, its light stretched into invisibility. But for the doomed traveler, time races forward toward the singularity. This relativity isn't just a quirk of physics, it's a metaphor for human fragility. Our civilization has existed for a cosmic eye blink, less than a heartbeat in universal time. Black holes remind us that the universe operates on scales we can scarcely comprehend, indifferent to our presence. Perhaps most haunting is what this scenario reveals about information. In everyday life, knowledge feels permanent, but black holes challenge that. The information paradox suggests that data swallowed by a singularity might be lost forever, violating quantum mechanics rules. It's as if the universe itself has a delete button with no recycle bin. Scientists like Hawking wrestled with this for decades, proposing solutions from holographic principles to hidden universes. The debate continues, underscoring how much we still don't know about the rules governing existence. So while Earth's odds of meeting this fate are astronomically low, the thought experiment crystallizes a profound truth. We're temporary guests in a universe of extremes. Black holes aren't just death traps, they're cosmic teachers. Their existence pushes our understanding to the brink, forcing us to question everything from the nature of time to the permanence of information. And in that questioning, we glimpse both our insignificance and our astonishing privilege to exist at all on a fragile blue dot in a cosmos where such wonders and terrors are possible. Hollywood loves black holes, but it rarely gets them right. Take Interstellar, the film that brought these cosmic monsters into the spotlight. Its depiction of Gargantua, the swirling behemoth, was groundbreaking for its time, with physicists consulting on the visuals to create the most accurate accretion disk ever put on screen. Yet even here, artistic license took over. The time dilation on Miller's planet, where 1 hour equals 7 years, is theoretically possible near a black hole's extreme gravity, but the tidal forces would have shredded the planet long before anyone landed. And that scene where Cooper falls into the black hole and emerges inside a bookshelf, pure poetry but zero physics. Singularities don't lead to tidy, navigable spaces, they're where the rulebook burns. Then there's the enduring myth that black holes are cosmic vacuum cleaners, greedily sucking in everything around them. In reality, they're more like gravitational traps. Unless you're practically on their doorstep, their pull isn't stronger than a regular star of the same mass. You could orbit one safely until friction or a misstep sends you spiraling in. And the portal trope, it's a staple of sci-fi, from Event Horizon to Thor, Ragnarok, suggesting black holes whisk travelers to other dimensions or times. General relativity does allow for hypothetical wormholes, but these would require exotic matter to stay open, something we've never observed. Even if they existed, the sheer gravitational forces would turn any would-be adventurer into atomic confetti before they reached the other side. Pop culture's other big sin, making black holes visible lurking predators glowing like neon signs. Real ones are invisible unless they're actively feeding. The iconic images we see, like the first photo of M87's shadow, are actually the absence of light, a silhouette against the hot gas swirling around it. And no, you wouldn't see a tidy hole like in Doctor Who. The warped spacetime around one would twist background starlight into a chaotic halo, a funhouse mirror reflecting the entire universe. But not all depictions are wrong. The Expanse nails the silent terror of a black hole's approach. No sound in space, just the creeping distortion of stars and the slow, inevitable pull. And Contact, based on Carl Sagan's novel, correctly shows that traversing a wormhole, if possible, would be a one-way trip with no guarantee of survival. These stories respect the science enough to ground their fiction in plausibility. The real tragedy of these myths, they overshadow the true wonder. Black holes aren't just plot devices or CGI spectacles. They're the universe's most extreme laboratories, bending light, stretching time, and challenging everything we know about physics. When films reduce them to magic doors or pixelated monsters, they miss the chance to explore the genuine mysteries that keep scientists awake at night. Like why some black holes hum at a pitch 57 octaves below middle C, or how information might escape their grip encoded in Hawking radiation. The reality isn't just stranger than fiction, it's stranger than anything fiction dares to imagine. From the moment Earth's orbit begins to wobble under a black hole's invisible pull, to the final, chilling instant when our planet dissolves into the singularity, this journey forces us to confront the fragile line between existence and oblivion. We've seen how tidal forces stretch continents like taffy, how time itself distorts near the event horizon, and how even the solar system would unravel in our absence. But beyond the catastrophe lies something profound. Black holes aren't just destroyers. They're cosmic puzzles reshaping our understanding of physics, from the way gravity warps light to the eerie paradoxes of quantum information. Consider the legacy we'd leave behind. Long after Earth's atoms spiral into darkness, light carrying our final moments would still race across the galaxy, a fading echo of cities, oceans, and faces frozen in time. Future civilizations might decode those signals, piecing together our story from stray photons. Or perhaps, as some theories suggest, our planet's essence could persist somehow, imprinted on the black hole's surface like a hologram, waiting for some advanced intelligence to read it. Here's the most humbling takeaway. The universe operates on scales that dwarf human concerns. Black holes remind us we're temporary guests in a cosmos where stars live and die in cycles we can barely fathom. Yet within that brevity lies our chance to explore, to question, and to marvel at phenomena that push the boundaries of imagination. So now we turn to you. If astronomers spotted a black hole heading our way with a century's warning, enough time to plan but not enough to escape, what would you do? Would you focus on preserving knowledge, forging global alliances, or pursuing impossible technologies? Let us know in the comments below, and if you're hungry for more mind-bending explorations of futuristic threats and cosmic wonders, hit subscribe. The universe is stranger than fiction, and we're just getting started.